So example 4 is pretty similar to example 3. This time we have a cubic polynomial. We're going to graph negative x to the third minus 5x squared plus 14x. We're going to find the x-intercepts and go from there. So we set it equal to 0, and we get 0 is equal to negative x to the third minus 5x squared plus 14x. Then you can factor out a negative x. You could factor out just x, but I like for my quadratic to have a positive coefficient in the front there. So if I factor out negative x, it changes all the signs. And we get negative x times x squared plus 5x minus 14. You can set each of those equal to 0 to find your solutions. Negative x equals 0 gives me 0. This one will factor into x plus 7 times x minus 2. Set those equal to 0, and you get negative 7 and 2. Okay? So then you could go to your calculator, enter that in. If you wanted, you could go to the table first to try to figure out a good scale. And this one, the min, at least in the table, the smallest value I see between my x-intercepts is negative 4 and negative 72, counting by whole numbers here. So on the screenshot, I did negative 100 for my y-min, 20 for the max, and got a good picture. But let's go to the calculator. So we can put in negative x to the third minus 5x squared. Oops, drop down out of the power here. Negative x to the third minus 5x squared plus 14x. And again, you can do what I did on the screen and do second and graph, look in the table and see that you need to go down past negative 72, or you could just do zoom 6 and start with this graph, which isn't good enough yet. We can see the max but not the min. But let's find the min. Second, trace, number 3. The x-intercepts are good here. We can do negative 7 as a left bound, and then 2 for the right bound using the x-intercepts there. Oh, went too far, but it'll still work. I should have used the 0 probably, but that's still the lowest point. So we get a min at negative 4.4, negative 73 if we round off. So we're going to want to plot that when we draw our final picture. Let's go ahead and find the max. Second, trace, number 4. And the max for the left bound, we can do 0. And the right bound, do 2. And then guess. When you set your left and your right bound, you're just giving it x values such that the max or the min is the largest y value in between those. And the x-intercepts work great on polynomials, especially if they run off the screen. And we get a max at about 1/8 if we were to round those. Okay? So that's enough that we know now to draw the picture. So let's see what I did on the screen here. So I found the min and the max. And then to draw my picture, I've got my x-intercepts. Do the good scale first. Again, no perfect scale here. Pick whatever scale you want, but you have to see the max and min. So my x-axis, I did the standard negative 10 to 10 by 1s. And we had a max at 8, so 10 would have been enough, but I went ahead and went up to 20. We had a min down at about negative 72, negative 73, I think it was. So I went down to negative 100. And so we plot the points that we know. We got the x-intercepts, 0, 2, and negative 7. And I drew that. Sorry, they're off just slightly because I was drawing it with an iPad, but they should be right on the numbers. And then we had at about 1/8 if we rounded, and then it was negative 4.4, negative 73 for that point, and then drawing the shape. And there we go. Okay. Let's go ahead and look at another one. This time the difference is we have to do factor by grouping on part A. So p of x is x to the third plus 5x squared minus 4x minus 20. So to find the x-intercepts there, I'm going to do factor by grouping. I can't factor an x out because of the minus 20, but we can pair them up. We have 4 terms. We pair them into 2 groups. Remove the greatest common factor from each group. The first one, we have x to the third plus 5x squared. We can factor x squared out, which would leave me with x plus 5. And then we're trying to match that. We could factor a 4 out of the negative 4 and negative 20, but if we do a negative 4, we're left with x plus 5. So the x plus 5's match, and we can factor that out, and we're left with x squared minus 4 times x plus 5. Set those equal to 0. You're going to get plus or minus 2 and negative 5 as your x-intercepts. Again, I'll just show the screenshots this time. You can enter it in. I went ahead and did that, and then look in the table between negative 5 and 2, and you see the highest value looks like 12, the smallest negative 20, at least on those numbers. So I did negative 25 to 15 as my window, and then graphed it, and there's the picture. And again, find the max and min with your calculator. I guess I should show that. So y equals, this time, positive x to the third. So we're going to have the positive in behavior there, plus 5x squared, minus 4x, minus 20. And I figured out, I'll go ahead this time, I figured out a window. I did, what did I do? Negative 25 to 15. By looking in the table at values. And count by 5 if we're going to go in those numbers. And there's our graph that we want to try to draw. And we know our x-intercepts. We got 2, negative 2, and negative 5. We need the max and mins. Second trace. I'll do the min first. So number 3. For my left bound, I'm going to use that x-intercept, which is negative 5. For my right bound, I'm going to use the x-intercept at negative 2. And then the guess. I must have done something wrong. Let me try that again. Second trace, number 3, left bound of negative 5, right bound of negative 2. Oh, I know. I chose min, and I'm looking for a max, right? See, it's finding the smallest value, and it's 0. So, sorry about that, but that's a mistake we make sometimes. Let's see. I'm looking for a max, so number 4, and then the left bound, negative 5, right bound, negative 2. Now, that's better. So we got, let's see if that matches what I had on the screen. Yeah, we've got about negative 3.7, 12.6 if we round to a decimal place or two. And then second trace minimum, that one's between negative 2 and 2. And we get the min that's down just past negative 20, so at about 0.36 or 0.4 or negative 21 if we were to round. So we got our max and mins, and we can fill all that in. Again, pick a good window that shows the max and mins. And we got x-intercepts at negative 2 and 2 and negative 5. And then we found the values that we just found. We had at about 0.4, negative 21, 0.4, negative 21, and then we had our max that we found, and draw it in.